Wow. Ricky, papá ya, no pida malo. Jangan buru-buru. Jangan buru-buru. Siapa yang makan? Ih, makan. Makan. Sinakaat ng mga ito dali mo.
My work is easy because I use Click. Here's how I keep track of all my tasks. I start by brain dumping everything I need to get done in a list view. Next,
This is one of the most comprehensive videos I've ever created, as you can see by the huge amount of notes I took for this video. I spent over a week reading the Prisma documentation, playing around with examples, and distilling down the most important topics. That way I could include everything you need to know in this one single video, and even though this is a longer video, it includes everything you need to know about Prisma, so you won't need to use any other resources other than this. I also have tons of timestamps in this video so you can jump around to the particular parts you care about, or come back and use this as a reference in the future. With that said, let's get started. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner, and we're going to be talking all about Prisma in this video. Now, you are going to need to have Node.js installed in order to follow along with this tutorial. I have a video covering how to install it. I'll link in the cards and description for you. And you're also going to need to have some type of database installed or a database on a server somewhere. I'm going to be using Postgres for this tutorial, but you can use pretty much any database you want. Just know that if you use MongoDB or another NoSQL database, some things may be slightly different, and that's because Prisma's generally built for, SQL databases, but you can use it with something like MongoDB if you want. Now, to get started with Prisma, what you're going to need to do is you're going to need to download all the dependencies for the project. Before we can download our dependencies though, we first need to initialize npm by typing npm init-y. That's going to give us a package JSON file, and then we can install our dependencies. So we can just type in here save dev, and that's because every dependency we need for this project is a development dependency. So we need to have Prisma itself, so we can type in Prisma. We need TypeScript, and that's because Prisma is built on top of TypeScript. You technically don't need TypeScript, but we're going to be using it in this project. We have TS Node, which gives you TypeScript definitions for Node. And we're also going to have here at types/node, and that again is helping us with our types in Node. And then finally, we're going to be using NodeMon, which allows us to refresh our server every single time we make changes. So if we make changes to our file, we can click save, and it's going to rerun that code for us automatically, which is really handy. Now, as soon as this is done installing, then what we need to do is actually create a tsconfig file. So I can just come over here, type in tsconfig.json, And this is going to be a file that contains all of our TypeScript configuration. And inside the Prisma documentation, it tells you exactly what you should type in here. I'm just going to copy this over. And this is the documentation that is recommended by Prisma for your TS config. Now, if you want, you can go to the Prisma documentation, which I'll link in the description, and it may have slightly different rules, but you can really play around with these rules or use a TypeScript config that you already have in your project. It really doesn't matter. Now, once we have all those dependencies installed and this TS config file created, what we need to do next is actually initialize Prisma. So if we type in npx prisma init, that'll initialize like Prisma and the schemas and migrations, all of that for us, but we can also tell it what database we're using by typing in --data source, -provider, and then just type in your database. In our case, we're using Postgres, so we can type in PostgreSQL, hit enter, and that's going to initialize some basic files for us, and it's going to use Postgres by default. So if we open up this Prisma folder, that's what's created. You can see we have this schema.prisma. And inside of here, we have just really basic code. This is going to be your schema file I'll talk a little bit about, but you can see we have a generator and we have a data source. Also, we have this .env file, which contains our Postgres URL. This is going to be the URL to whatever database you're using, so you would need to type in your own specific URL here. And also we have a git ignore that just contains that env variable and this node modules, just to make sure none of this goes into our GitHub repository. Now, one other thing to note, if we go back to this Prisma file, is you'll notice I have really nice code formatting in here and code highlighting. That's because I have an extension installed called the Prisma extension. If you just type Prisma in, this is the extension you want to look for. It's going to give you syntax highlighting and code formatting. So if I come into that file, let's just go back to it real quick. And I just make some changes, like I add a bunch of, tabs in here, for example, and I click save. It's going to automatically format my code for me, and that's because I have auto formatting set up inside VS Code. But if, for example, you didn't have auto formatting set up, so if I just go into my settings, we'll just come in here, preferences, settings, and I just type in format. Actually, I think I need to go edit my settings as JSON here. And if I find Prisma, you can see here Prisma, I have my default formatter to set to the Prisma formatter, and I have it set to format on save. If I comment this out and I go back to my Prisma file and I make changes and I save, you can see it doesn't auto format. But Prisma has a formatter built in where you can type in npx prisma format, hit enter, and that's going to format your schema file for you automatically. So you can do both ways of doing this. I obviously prefer to have it inside my settings, which is why I have it auto format on save, just like this. So that way when I make those changes, click save, it automatically formats and I don't need to run that code in the console. Now, very briefly, I want to explain a little bit about what this generator and this data source is before I continue going on in this tutorial. And essentially the generator is what your code is generating into, because this right here is a schema file. You're going to define a bunch of code for your database in this Prisma format. It's not SQL, it's not NoSQL, it's the own format of Prisma. It's completely separate from any other type of, SQL formatting you would think of. So you're going to define your code inside this Prisma specific format. And then when you run your generator, what are you going to generate your code into? In our case, we're generating this Prisma client.js. And this is just the default. We're saying, hey, take all of this Prisma code and convert it using the Prisma client.js formatter, which is the default generator that we care about. And this is what 99% of your projects are going to use. But let's say you're creating like a GraphQL API. There are actually different generators you can use that generate a bunch of GraphQL API code for you automatically based on your schema. So if you want to have an extra step, an extra layer added for like GraphQL, you can do that with a generator. For our example and everything in this video, we're going to be using the default generator because that's what you're going to use 99% of the time. Now, data source, this is pretty self-explanatory. And here we have our provider, which is just where our data is coming from. In our case, we have Postgres. You could use MySQL, you could use MongoDB, whatever you want. And then we have the URL, which is defined in our environment variable right here. Now, this URL, you actually need to make it your actual URL. And in my case, our URL here has a user of Postgres. The password is just password. And then this is 5433. And our database here, we're just going to call test. You can call the database whatever you want. We're just going to be using a database called test. Now, it is important to note that whatever database name you use, that database must already exist. I already have a database on my computer called test. It's just completely empty, and that's what we're using for this project. Now, back to that schema file that we have here, that .prisma file, the next thing we want to do is actually define our schema. And the schema just represents like all of your different data. And we're going to define the most basic schema at first, just to get something started before we start diving into the more complex intricacies of the schema. So we want to create a model, and you just type in model and then give it a name. In our case, we'll create a user model. So we have a model called user, and inside these curly brackets is going to be all of the code for our model. And you can already see we have syntax highlighting saying, hey, you know what? Our model doesn't contain an ID. And every single model inside of Prisma must have some form of ID. So let's create an ID, and we're going to make this ID an integer. So we're going to type in int right here, and we're going to define that it is an ID by putting this @ symbol right here. Now, all of this syntax is fairly confusing to get started with. We're going to deep dive into exactly how this works, but first I want to just define the most basic model. That way we can see the whole top to bottom workflow of Prisma before we dive deep into each individual section. And the last thing I want to do is define a default value, and this default value I just want to auto increment. And you can see that we have awesome code syntax suggestions based on this Prisma extension, which makes working in the Prisma environment so easy. So we have a user that has an ID, and we're going to give it a name, which is a string. Now when I click save, you can see everything auto formats for me, and this looks really good. We now have a user model that's defined in our schema with an ID and a name, super basic stuff, and that's all we're going to do to start here. Now, but defining this model right here, we haven't actually done anything with our database. Prisma and our database are completely separate from one another. They are able to interact with each other, but by defining something in Prisma, it doesn't actually do anything to our database. What we need to do is we need to tell Prisma, hey, you know what? I'm done making changes to my schema. Can you apply them to my database? I want you to migrate my changes from what I had before, which was nothing. I want you to add this new model to my database. To do that, we need to run a command. This command is called npx Prisma migrate, and then you can optionally pass in a name as well, and we also want to specify that this is for development only, so we type in dev here, and that means we're going to be pushing a migration that is in our development environment, and we're going to give it a name of init, because we're initializing our database with this new model of user. We click enter, and it's going to run through a bunch of code. Essentially, it's going to create a brand new migration file, and that migration file is going to be able to interact with our Postgres database and make all of these changes. And you can see right now it just did that. Your database is now sync with your migration here, and we have this migrations folder. If I open it up, you can see inside of here, we have a SQL file that contains our migration, which just says, hey, create us a table. It's called user.
Is your agency using WordPress to build websites? That's like carving a chicken with a handsaw.
Give it an ID and a name, and a primary key of ID which auto increments. Really basic stuff. You'll also see something really important here. It says generated Prisma client, and it says put it in my node module. Folder at Prisma/client. Essentially, we have created a brand new Prisma client. And this client is that thing from the generator. We're saying, hey, create me a Prisma client JS. Whenever I change all my code and I make changes to my database, such as adding this model, I want you to update my client code, which in our case is this Prisma client. And that's what it does. Every time you make a migration, it's going to update your client for you. And that client is essentially all of the code for interacting with your database. Now that we've added this user model, our client added a bunch of code automatically for us that allows us to interact with users, create them, read them, update, delete them, and so on. And all of it is typed with TypeScript, so we have this nice type safety blanket. Now, unfortunately, we don't actually have a client yet because we haven't installed the client library. So we need to do that now. We can type in npm I at Prisma/client, and this is going to install the client that allows us to actually generate and use this client. And when we first install the client from doing this migration, we already have everything generated, but if you need to manually regenerate your client, you can type in npx Prisma generate, and what that's going to do is it's going to go through all the steps of generating based on whatever provider we want, which is the default one, and you can see that now we can start using our Prisma client because it automatically generated it for us and stored it in that particular location. And again, that's all of our Prisma code in that one place. So let's just copy this little bit of code it gave us, and we're going to create a brand new file called script.ts. And inside here, I'm just going to paste that code. And this allows us to access our Prisma client. So now we can type in, for example, Prisma dot, and you can see we have a bunch of different methods as well as this user right here. And user represents that user table we created right here. It's automatically generated for us. So we can say .user, and you can see we have a bunch of different methods. For example, we could do like a find first to get the very first user based on different criteria we pass it. Now, I'm just going to paste in a little bit of code right here, and this code is essentially just a really simple way of using async await. We just created a function, an async function, called it main, and then down here we're catching any errors and printing them out, or at the very end we're finally disconnecting. So as soon as we're done running all of our code, we're disconnecting from the Prisma database, and that's something you don't have to technically do, but it's probably a good idea to disconnect when you're done, but it'll automatically disconnect for you as soon as your program finishes running. So in our case, it doesn't really matter because it would automatically disconnect, but adding this in there is also also just fine. So now inside main here, we can write any of our Prisma code. And the reason we put this in an async function is because almost everything in Prisma is asynchronous. So it's going to run, it's going to wait, and then it's going to give you a result. So using async await makes it easier to work with. And if you're unfamiliar with async await, I have a full video covering it. I'll link in the cards and description for you. So what we can do inside of here is we can say prisma.user, and let's create a brand new user. We'll just say create, and we're going to pass in data. That's how we specify what we want to create. We say data, and we pass it an object that contains all the data we want. In our case, we have a name. We can say name is going to be Kyle, just like this. Now this is going to create us a brand new user. And if we make sure we await this by just saying that we're going to have a user, and we're going to await right here, we can console.log out our user. So we're just waiting for Prisma to create a user for us. It's going to put it in our database with the name of Kyle. It's going to return that user, and then we can log that user out right here. So in order to run this program, let's go into our package.json, and in our scripts section, let's create a script called dev start. I'm just going to say nodemon script.ts, and that's going to automatically compile and rerun our script ts file every time we make changes. So I can type in npm run dev start, which is that title or that script we just created, and it's going to start up ts node. It's going to run, and you can see it just created a brand new user named Kyle with an ID of 1. Let's say we want to create Sally. I can come in here, change the name to Sally, click save, and now we have an ID of 2 with the name of Sally. Super straightforward. Also, if we wanted to get all the users, we could just say, for example, find many, and we can come in here and we can just say this is going to be all of our users. Click save, and that's going to generate all of our users. You can see we have our user Kyle and our user Sally. And that right there is like the basic overview of Prisma from top to bottom. At the very top, you create your schema, and the schema defines the data source you're using, so your database. It defines the generator for how you go from your schema to your TypeScript code, and it defines all of your different models and enums and everything related to your database, all inside this one file. Then, once you're done with that, you create your migrations, and your migrations allow you to make changes to your database based on the changes you made in this file. So when you update this file, it'll automatically create a migration that moves you to the next step, so your database is always up to date with this file. Also, in doing that migration, you're updating your code with this generator. This generator creates a library for you, this Prisma library right here, that allows you to interact with your code through this Prisma library, so you don't have to write raw SQL queries. So this schema file essentially defines your entire database. It allows you to migrate your database, and it allows you to interact with your database. This is like your single source of truth and is really important to understand. And that's why in this next step of this tutorial, I'm going to be covering everything you can do inside this schema file for Prisma, and it is a lot. Now first, I want to go a bit more in depth on generators and data sources before we really dive into the complex part, which is our models. So when it comes to data sources, you can only ever have one single data source, and that's because Prisma is directly connecting to your database. So you can only have one database that defines all of your data, so only one data source, and it must have a provider, which is the name of your database you're using, and it must have a URL which links to that particular database. Also, it's really important that you use environment variables for storing your database URL. That way all of your password information is safely secure inside of this file, and you can also change the database that you're using for development, staging, and production, and so on. Now the next thing that we have is a generator, and you can have multiple generators. For example, we could have a generator for our Prisma client, and we could have a generator for some type of GraphQL API. There's tons of different NPM libraries out there for different generators, so you can take a look at them if you want, but in our case, we're going to be using just this one generator. Now in order to define a generator, all you do is you give it the provider, and the provider just links to the name of that generator, and whatever generator you want will tell you what the code here should be for the provider name. So now let's move on to the more complex part, which is models. Models essentially represent the different tables inside your database where you can store your data, and each model is essentially composed of a bunch of different fields. Each row you see right here is considered a field, and a field is composed of 4 different parts. The first part right here is just the name, really straightforward. This is our ID field. This is our name field. We could have, for example, an email field just like this, and that's just the very first part here is the actual name. Then the next thing that we have after that is going to be the type of that field. So we have an integer, here we have a string, and so on. After that, we have 2 different things that are optional. So you are required to put a name and a type on everything, but optionally you can have a field modifier and you can have attributes. So a field type modifier would be like saying, hey, you know what? The name is optional. So we're going to put a question mark here, and that says that this name field is optional. We're going to cover all the different type modifiers in a little bit, but that's what those would look like. And then attributes are all these things that start with the @ symbol. For example, we're saying this is an ID field. We're giving it a default value. Those are all your different attributes. And again, they're optional. Our ID field has a bunch of attributes, but our name and email field do not. So now let's dive into some of the different types of fields that we can have. I'm going to cover every single field type that's possible. So far, we've covered the integer field type and the string field type, but there's a ton of other field types. For example, let's have an isAdmin field, and this is going to be a Boolean. So we just say our type right here is Boolean. That's going to be one more type that we can cover. Another type that we can cover is something called a big int. For example, if we had like a large number, and this is a super large number that we wanted to be able to like finely tune and cover, that's going to be larger than a normal integer, you would want to use a big integer to represent that, and we could just type in big int here. We don't really have anything that would be big int related in this application, so we're just going to remove that for now. Another type of field that you could have would be a float. I'm actually going to create a new model, and this model is going to be for a post. And this post is going to be like a blog article that someone wrote. And this blog article can have a rating, so like a 5-star rating. And this rating can be anywhere between 1 and 5 stars, so maybe it's like 4.7. Well, we know that this is going to be a decimal value, so it's going to be a float. And that's because a float essentially represents a floating point number, or a number that has decimal places. There are also different types of floats that you can have. For example, you could have a float or a decimal. These are both very similar in that int and big int are almost the same thing. A float is kind of like less specific. It's a more general floating point number, while a decimal can represent a much wider range of floating point numbers. So if you need to be really accurate with your floating point numbers, decimal might be the way to go. Otherwise, for most use cases, float is going to be just fine. Another type of field is going to be a date-based field. So for example, we could have like a created at, which is going to be a date time, and we can have an updated at field, which is also going to be a date time. Date times just represent essentially a timestamp, so like a date and a time. That's all they are. It's the only time-based type that you can use in Prisma. Now those are most of the main data types you're going to use, but there's a couple other unique ones that you might run into. For example, you might have like user preferences. So we could say preferences, and this is just going to be a JSON object, so we can use the JSON data type to represent that. Not all databases support the JSON data type, but Postgres, for example, does, which is why we can use this. If we were using something like
What's up guys? In this video, I'm going to share with you how to come up with business ideas that are actually good. Welcome to How to Start
SQLite, for example, is our database. You can see immediately we're getting an error that says, hey, JSON's not supported in that database. So it's really nice that it takes care of that for us. Another type that you're going to run into is the type of bytes. So we could come in here and, we could say that we want to have like a blob, and this is going to be a type of byte. So like if you're storing like file data or like really big data that you need to convert down to just raw byte information, you could use bytes to store that. A lot of times you're not going to really run into this data type that much, so it's not super important. Another data type that you might run into is the unsupported data type. And this is a really interesting data type in that it is not something you're going to ever write yourself inside of a Prisma schema file, but Prisma allows you to actually take a database that already exists and convert it to a schema file. And since Prisma doesn't support every single type of data type in the entire world, there are going to be some that are unsupported, so it'll list them as unsupported if you take an existing database, convert it to Prisma, and it does not support that data type. But if you're just starting out with Prisma, you're never going to use this data type at all. Now, the last type of data that you could run into would be like data that represents another object. For example, if we have a post, we could have an author, and that author could be a user. Now, in order to define this type of relationship data, you actually need a lot more information than just writing out there's an author with the type of user. So when I click save, you're going to notice it's actually going to auto-populate a lot of information for me. You can see I click save, and automatically it added this post reference inside of our user, it added this user ID, and it added this author tab right here, which has this huge relationship section. This is essentially how you make different relationships inside of Postgres. And I'm going to cover the 3 different types of main relationships you have. You're going to have a one-to-many relationship, which is where, a post has one author and a user has many posts. One-to-many. We're going to have many-to-many. For example, one post could have a category, and a category could have many posts. So each post has many categories, and many categories have many posts. So there's a many-to-many relationship there. And then also I'm going to be covering what happens in a one-to-one relationship. For example, if a user has like a table of preferences, each user has one reference in that preference table, and each preference has one user it links to. Those are the 3 different types, and we're going to cover all 3 of them here. So the first one is one we've already started to cover, which is a one-to-many relationship. So a user is going to have many posts. So what's coming here, we're going to say that many post, and it's going to be a post array. And this array syntax right here is a field type modifier. And there's only 2 modifiers you need to know of. There's the array one, which says there could be multiple of this thing. Now, the last type of data that you could run into would be like data that represents another object. For example, if we have a post, we could have an author, and that author could be a user. Now, in order to define this type of relationship data, you actually need a lot more information than just writing out there's an author with the type of user. So when I click save, you're going to notice it's actually going to auto-populate a lot of information for me. You can see I click save, and automatically it added this post reference inside of our user, it added this user ID, and it added this author tab right here, which has this huge relationship section. This is essentially how you make different relationships inside of Postgres. And I'm going to cover the 3 different types of main relationships you have. You're going to have a one-to-many relationship, which is where, a post has one author and a user has many posts. One-to-many. We're going to have many-to-many. For example, one post could have a category, and a category could have many posts. So each post has many categories, and many categories have many posts. So there's a many-to-many relationship there. And then also I'm going to be covering what happens in a one-to-one relationship. For example, if a user has like a table of preferences, each user has one reference in that preference table, and each preference has one user it links to. Those are the 3 different types, and we're going to cover all 3 of them here. So the first one is one we've already started to cover, which is a one-to-many relationship. So a user is going to have many posts. So what's coming here, we're going to say that many post, and it's going to be a post array. And this array syntax right here is a field type modifier. And there's only 2 modifiers you need to know of. There's the array one, which says there could be multiple of this thing, and there's question mark, which says it is optional. Those are the only 2 field type modifiers out there, and you're going to see them all the time. So we're saying each user has multiple posts, and they are the type post, and there's an array of them. And then inside of here, our post has this relationship. The field right here is referencing what field inside of our post table is referencing the ID inside of our user table. So we're saying that the user ID field in our post right here references the ID field in our user, and those 2 should be the same. So whenever the user ID is the same as the ID, that means they are linked together. It's like a foreign key relationship if you're familiar with SQL. Now in our case, we want this to say author ID. So we can change that to author ID instead of user ID. And now that's going to link this author ID column with the ID inside of our user table. Another thing that I want to show you is that you can use more than just auto-incrementing IDs. You can actually use UUIDs as your ID, which is something that I find a little bit more common to use UUID instead. So we can just type out UUID right here and make this a string type and move this down here as a string type. And now we're going to have UUIDs instead of auto-incremented IDs. And that's just going to be a little bit more secure because people can't just change the ID from 1 to 2 and access new information. UUIDs are completely random and unique. Also, our post should have its own ID, so I'm just going to copy this down, and we're going to give our post an ID to get rid of those errors that we had. Now that right there covers how to do a one-to-many relationship. What happens if a user can have 2 references to a post? For example, we're going to have posts that they wrote, so we're going to have written posts, and we're also going to have favorite posts. So for example, they favorited some posts, so we're going to have favorite post and written post, and both of those are going to be a reference to post. And then down here, we're going to have both a author, and we're also going to have, I'm just going to copy this real quick, a favorite. So we can say favorited by and favorited by ID. So now this is saying that a post can be favorited and a user can have multiple favorited posts and multiple posts that they have written. But you'll notice we get an error. Essentially, we're saying, hey, we can't, validate this because it's ambiguous. Which one is written post, which one is favorite post, because they don't actually say. And we just make sure we update this right here to be favorited by ID. These relationships both point to the post table, but we don't know which one of these relationships is pointing to. We need to give these relationships a name. So we can pass in a first property to this relationship function. We can just say written post, name it whatever you want, it doesn't matter. This is just a label. And this label can be shared with all of the other fields. So up here, we can say at relation, and we can say that this is going to be a written posts. And down here, this is our favorite posts. And our relation for this one is going to be that favorite post. So what we've done by this is by giving these names is we disambiguated it. We've said this written post array right here references this author and author ID section, while this favorite post references favorited by and favorited by ID. So you only need to do this extra step is if you have 2 references to the exact same table. Normally you don't have this, but in our case, we do have this scenario. Also, before we move on, I'm going to make this user field right here for favorited by optional. So I'm just going to come in here and put a question mark to say, you know what, our favorited by is optional. We also need to make sure our favorited by ID is also considered optional because both of those fields are linked to the same thing. So that right there covers a one-to-many relationship as well as disambiguating multiple one-to-many relationships. But what happens if we have a many-to-many relationship? Let's say that we have another model called a category. In this model category, we're just going to give it an ID. I'm just going to copy this ID over here. So we have an ID and it can have multiple posts. So for example, we'll say post is equal, or sorry, not equal, but we can have this post array. So essentially one category can reference multiple different posts, and a post can have multiple different categories. So we can say category array. And if we save, you'll notice we don't need to do any fancy @relationship setups. It just automatically knows that our categories right here is referencing this category model, and this post right here is referencing our post model. And it's automatically going to create a join table between the two that is going to hook up all these relationships for us. So all of that complicated join table stuff that you would normally have to do for many-dimensional relationships is taken care of by Prisma, and you don't need to worry about it at all. So right here with this little bit of code, all of our posts can have multiple categories, and all of our categories can have multiple posts. Now the final type of relationship I want to talk about is a one-to-one relationship. So we're going to say one user is going to have one set of user preferences. So instead of using this JSON right here, I'm going to bring this into its own table. So we can say we're going to have a model called user preference.
Want to create your own AI-powered application? Join the Link Hackathon and compete for $40,000.
Just like that. And this user preference is going to have an ID. So let's just paste in an ID. And we're also going to give it a field like email updates, for example, which is a Boolean. So we're saying, hey, you know what? Do you want to receive email updates or not? That's all this is saying. And now we want to reference the user table from our user preference. Now, since we're doing a one-to-one relationship, you can store the relationship on either the user table or the user preferences. In our case, I'm going to store it on the preferences. So I could just say user is at our user table, and we can also have a user ID, which is for that user table. This is just a string. And if we save this, you can see it automatically does a lot of that relationship for us. And we don't want this to be an array though. We want this to be a one relationship. So we can just put a question mark here. We're saying optionally, this is going to have a user preference, just like that. And you can see here, this automatically marked itself as unique because this user ID must be unique. The reason this must be unique is because we can only ever have a preference reference one user. We can't have multiple preferences referencing the same user. That's how this one-to-one relationship works. Now, speaking of this like @unique attribute, let's actually talk about a lot of the different other types of attributes besides the relation attribute. Because so far we just talked about relation, ID, and default, but there's a ton of other attributes out there. And one of them is the unique attribute. For example, we want our emails to be unique. So we can just put an @unique on our email, and now every single email is going to be unique. Now the last kind of attribute I want to talk about, at least field-based attribute, is going to be the updated attribute. Down here we have this updated field, and if we give it the attribute updated what that's essentially going to say is that every time we update this post, it's going to automatically set this updated field, whatever we specify as updated as the current timestamp. So it's automatically going to update that for us. We don't have to worry about manually keeping track of that updated time, which is super cool. Also, created we should probably give it a default of now. So we can just say default now, and that's going to default to the exact current timestamp when we create this. So that way when we create this, we don't have to worry about manually setting this time. Now, before we start talking about the last set of different attributes, which are block level attributes, I want to define a few additional rows to all of our different tables. So for example, we're going to give each one of our posts a title, which is going to have a string. We already have our rating. I'm going to change this to average rating just because it makes more sense with that float specific type. We have our created we have our updated we have our author, favorited by, favorited here. All of that is looking really good. Down here in our category, I want to give this a name, which is a string. And up inside of our user, I want to give our user an age, which is going to be an integer. Also, down here, I want to make this unique. So we're going to say that our name is unique. So that's going to be like the basic bare bones of our schema, but there's something else we can do besides just these single field level attributes. We can actually do block level attributes. Now I want to discuss a little bit the difference between the two. A field level attribute applies to the field. As you can see, our ID has the ID attribute. It has the default attribute. They're in the same row as our field, and they also have one single symbol in front of them. Now a block level attribute goes inside of these curly braces and it's on its own line completely, and they have two symbols in front to represent that this is a block level attribute. For example, what we could do inside of here is we could create a block level attribute on uniqueness, and we could say that inside of here, we must have a uniqueness constraint on age and name. We cannot have two people that have the same age and name. So we could just say age, name, just like that. And now what this single line of code right here is saying is that inside of our field, we must have our age and name be unique. And let me just get rid of those quotes. That was an accident on my part. So now we cannot have two users that have the same name and the same age. We can have two users that have the same age and different names, or the same name and different ages, but if you have the same name and the same age, it's going to throw an error because we have this uniqueness constraint. We could also specify an index. So I'm going to come in here and I'm going to say we're going to have an index. And let's say that we want to create an index on the email field. So we could have an email index. And this is going to help with things like sorting and performance. sequence. And we could also index on like email and name if we wanted, for example. But in our case, we're just going to index on email because what if we want to like query by email? It would be good to have an index on that. Now, the last type of block-based attribute I want to talk about is going to be the ID attribute. So if we come in here, we can actually create an ID attribute. And if we just comment out the ID up here, we can create a composite ID. So essentially an ID that contains two different things. So here our ID could be an ID that is on the title, and it could be on the author ID. So now we're saying that instead of having a specific ID, we're saying that our title and our author ID represent our ID for the post. So we must have a unique author and title combination, and that'll be corresponding to our ID instead of having this auto-generated ID up here. Now in our case, we don't actually want this, so I'm going to remove this, but I just want you to know that this is an option that is available. Now that pretty much covers 99% of everything you need to know about models. There's really not much else to learn, but there is one other type of data source generator model that we want to talk about, and that is an enum. So if we come down here, we can create an enum, and this enum we're going to call role. Now this role enum is going to have two values. We're going to have basic and admin. And right here, that'll help us define how our user is there an admin or not. And this is admin field. Let's actually just get rid of this and replace it with a role, which has the type of role. And by default, we want them to be a basic user. Now we have a bunch of different roles, and as we add more roles, we can come in here, we can say like, oh, we now have an editor role, for example, and that's just going to be defined inside of this enum. And this is really nice if you know a field only has a few set values that it can be, like basic, admin, editor. If you define an enum, it's going to make sure that when you actually start writing out your code, it'll only allow you to specify one of those specific values instead of just any value at all. So if you have a hard-coded list of values that something can be, using an enum is a great way to do that. So that right there covers everything you need to know. I mean, we covered models, data sources, generators, enums. It's everything you need to know about the Prisma schema. And if there's anything else that you need to know beyond that, it's super niche and you're probably not going to use it very often. So now that we have our entire schema written up, let's actually migrate our database to include all this new information. We can type in npx prisma migrate, and we could say dev, and if we don't give it a name, we just hit enter, it'll just ask us to specify a name. So if we just give it a second here, it's going to ask us to specify a name, and we can just give it any name that we want. But it looks like we actually ran into an error. If I scroll up here, it says we found changes that cannot be executed. It's trying to add the column age, which is required, but there's no default value, and there's two rows in our table that have that value. So this is nice. It's doing validation for us, being like, hey, you're trying to do something, but it's not going to work. So for now, what I'm going to do is I'm just going to go into our script file here. I'm going to delete everything. So we're just going to see. We're going to delete all of our users because we don't actually need them. It's fine. We can get rid of them just to start at a clean slate. npm run dev start. If we just run that, that should hopefully delete everything from our database. And then when we run our migration, it'll hopefully work just fine. So that ran everything. And now what we can do is run our migration. And hopefully we should no longer have any errors because those users that we created when we were testing are no longer there.